Hello everyone. In this video I will give an overview of two modifications I made to my DM6234P Plus optical tachometer. However, these mods may apply to most tachs using the same processor as mine. In any case, generally the approach will be the same. After that I will cover a circuit I designed to allow hands-free operation of the tachometer, and also give a few clips of some demonstrations. First, my disclaimer. You can easily ruin your tach if you're not careful to make sure your voltages and connections are correct. Having said that, the first mod I will cover is the addition of a DC input jack. I installed a mono audio jack and connected it directly to the batteries. In addition, it required an 8-volt DC adapter and 4 rechargeable AA batteries. This mod in particular can cause damage if the DC adapter used goes over voltage. So you may want to make sure you have some rechargeable batteries in there to regulate the voltage put out by your DC adapter, or just make sure it's a good quality adapter. The next mod required reverse engineering the tach. The first thing I did is find where the signal goes into the processor and installed a switch to allow switching between the tach's logic, in other words normal operation, and an external signal source, which could be a hall sensor or directly connected to a pulse motor circuit, for instance. To make things neater, I installed a stereo jack so the external signal can easily connect and disconnect from the tach. The jack has a signal in and DC out so that a small external circuit can be directly powered by the tach. The downside to this mod is that if, for instance, I take a measurement from a rotor with more than one magnet, the reading is off by a factor of the number of magnets. So a 4-magnet rotor read by a hall sensor, for instance, would have an RPM of 4 times what it really is. Nothing a bit of math won't fix, but annoying and fun to fix that problem. That's where the external circuit I designed comes to the rescue. It has a binary ripple counter and switches to adjust for the number of magnets. The downside to this simple approach is that it only works for 2, 4, 8, 16, etc. magnets on a rotor. The other upside is that a reading can be made if an IR diode is added at the circuit's output. So you can just aim your tach at that IR diode and you'll get a reading. This eliminates the need for the external signal input to the tach, which is a big upside. I designed it so that it runs from the tach's batteries or its own supply, so this circuit can run standalone and not draw anything from the tach or from your circuit running your pulse motor. And I'm directing this primarily at pulse motor builders because that's what I do. So I'm sure a lot of people out there are doing that. I will leave you with this demo of me pointing the IR diode at an amplified speaker I outfitted with a light-dependent resistor in order to take laser audio input. With it, you can hear the pulse motor. Hopefully you all have found this at least interesting, if not useful, and thanks for watching.